Hi and welcome to this tutorial. This one's over knowing how the elements are arranged and then they're arranged in groups and periods, and it's done by repeating patterns and relationships. Hi and welcome to this tutorial. This one is about the periodic table and why and how the elements are arranged the way they are. So hopefully you're going to understand by the time that the periodic table is arranged into groups and periods by repeating patterns and relationships. What is common among a family of elements? Well, a family, if this was your periodic table, rough sketch, a family goes up and down, okay? And they have the number of valence electrons in common. Number of energy levels is the period. They can't have the same number of protons in the nucleus because that would mean it was the same element, and they can't. The shielding effect is not the correct answer. So, correct answer, what is common among a family of elements? It's the number of valence electrons. Why do elements in the same family groups on the periodic table have the same properties? Well, they can't have the same atomic number and atomic mass number because this is equal to the number protons, and no two different elements can't have the same number of protons, so that's wrong. They have the same number of electrons, that's just not true. They have the same number of valence electrons, that's why they have similar properties. And again, they can't have the same, they have very similar mass and atomic numbers? No. Especially when you're going across a long one, you're going to find that the atomic numbers are very different. Okay? The alkali metals have similar properties due to the number of valence electrons. And guys, what did we already learn? That if they have the same number of valence electrons, they're all in the same group. Okay? And group and family are interchangeable. We use those terms interchangeably. Okay, so again, if we have the same number of valence electrons, we're in the same, what's that magic word? Group. Elements in the same group on the periodic table they don't have similar mass numbers or atomic numbers, masses, sorry. They don't have similar physical properties and mass numbers, because remember, mass number is the number of protons plus the number of neutrons. They don't have similar chemical properties and atomic masses, but they do have similar chemical and physical properties. They react the same, guys. They behave in the same manner, and some of them even kind of look like each other. Okay, use the periodic table to answer the question below. Which of the following pairs share similar properties? Okay, we're talking similar properties. That is equal to the same family or group, which means I'm looking for people in the same family. Bromine and iodine, they're in the same family because remember, groups go up and down, they're columns. Oxygen and iodine, no, because oxygen is here and iodine is here, so that one doesn't work. Fluorine and neon, they're in the same period, but they're not in the same family. Because remember, families and groups, they go up and down. Hydrogen and helium, again, same period, but not the same family. So again, which of the pairs have similar properties? Bromine and iodine. Why? Because in their same family, or if you want to use the word group, it means the same. Use the periodic table to answer the following question. Answer the question below. Which of the following elements will react similarly to selenium? Well, what have we learned? That if it's going to react similarly, it's going to be in the same group / family, depending on which word you want to use. So, what's the correct answer, guys? Hopefully you're already looking at your periodic table and you see selenium is here, Se, and germanium, Ge. Let's see if I can even find it today. Is right here, so they're not in the same family, so that's not going to work. Xeon, over here, not in the same family. Sulfur, oh look, that's in the same column, which means it's in the same family, so that's a possible. Let's just double check. Titanium is all the way over here. Again, same period, but not the same family. So the correct answer is sulfur. There you go. Which group of elements would be expected to have very similar properties? I hope you're thinking that they should be in the same family, because if you're thinking that, you're on the right track. Okay, so the correct answer here, what is it, guys? Again, you might want to go back and look at the previous slide. This question really should have a periodic table, but it's a good example of if you're taking a test and you don't have the same periodic table, go back and look at one if there's one used on another question. Okay, it's going to be oxygen, sulfur, and selenium because they're in the same family. Nitrogen, oxygen, and fluorine are in the same period, and we want a column up and down, and that's what oxygen, sulfur, and selenium are. Sodium, magnesium, and potassium, they're just kind of clustered around each other, so that's not the right answer. Neon, sodium, and potassium, they're in different periods, and 2 are in the same family, but not all of them. So the correct answer is A, oxygen, sulfur, and selenium. Okay. Next question. When comparing noble gas family and halogen families on the periodic table, which of the following statements are true about the chemical properties? Okay, they have similar to each other because they're side by side. No, things can be very different if they have a different number of valence electrons, so that's the wrong answer. They are different from each other because they are side by side. No, not necessarily true. They are similar to each other because they have the same number of valence electrons. That one is totally false because they're in different families. They have different number of valence electrons. They are different from each other because they have different number of valence electrons. That's your best answer, guys, right there. Again, different families have different number of valence electrons. Use the periodic table to answer the question below. Where are metals located on the periodic table? Guys, your metals is everything to the left of the staircase, including these guys down here. Those are all metals. So it's to the left of the purple, which is metalloids. These are metals. Okay. Next question. Where are the nonmetals located on the periodic table? Well, if we know that the metals are are most to the left side, where are we going, guys? Where do we need to go? Okay. So we know that they are on the far right. There's our nonmetals. Most of our nonmetals are gases. If you didn't know that, just an FYI. Okay, they're not in the middle. Those are transition. Along the bottom is our lanthanide and actinides, and those are metals. On the far left, that would be like over here, and there's metals. So it's on the far right of the periodic table. The location of metals and nonmetals on the periodic table are because of their, well, it's not because of their energy levels, and it's not because of their atomic mass, because we did used to arrange the table based on that, but we don't anymore. And it's not because of atomic numbers. It's because of their number of valence electrons. Which of the statements below correctly describes where fluorine is located on the periodic table and why? So what you should do is, first, is fluorine a metal or a nonmetal? It's a nonmetal. Just helps you out. Okay, so any answer that says it's a metal is wrong. So A and B. Okay, now C says it's to the right. Well, that makes sense because we know everything to the left of the metalloids is a metal. So that makes D wrong. So C is the correct answer. Again, all your nonmetals are to the right of the metalloids. Which of the following is properties of a metal? Are they malleable, ductile, and good conductors of heat and electricity? Malleable, dull, and good conductors of electricity and heat? Are they ductile, shiny, and poor conductors of heat and electricity? Are they ductile, malleable, and poor conductors of heat and electricity? Okay, first thing I want you to know, what are most of the wiring in your house made out of? If you said copper and you realized copper was a metal, then you should realize that metals are good conductors of heat and electricity, which they are. So that makes C and D wrong. And they are malleable, and most metals are shiny, so B is wrong. Malleable means they're able to be bent and shaped, and ductile means they'll be able to be basically pulled into wires. Okay? Which of the following are properties of nonmetals? Well, they're not metals. So if metals are good conductors of heat and electricity, then chances are nonmetals are poor conductors of heat and electricity. So if you use that logic, which is the correct logic, A is wrong and C is wrong. Why? Because they're saying they're good conductors, and they're not. They're bad. Okay? And nonmetals, most of them are gases at room temperature, so that would make it very hard for them to be malleable. So they have a very dull luster, and they're poor conductors of heat and electricity. Is cobalt a metal or a nonmetal? Okay. It is a metal because it is dull and a poor conductor of electricity. Well, first off, cobalt's a metal. It's in the center of the periodic table, which means it's a metal. It is a metal because it is ductile and good. Well, that's what a metal does, so that's a good chance. It is a nonmetal. We already said it was a metal, so those two answers are wrong. Correct answer is B. A metal is ductile and a good conductor of heat and electricity, which is what cobalt is. Is chlorine a metal or non-metal? So look at your periodic table, and it's all the way over on the right side, so that means it is a non-metal. So anything that says it's a metal is wrong. It is a non-metal because it is period 4 and it's ductile and a gas. Period 4 could be metals or non-metals. By saying that, it doesn't make any sense. Periods go across, remember? It is, and periods do stretch across metals to non-metals. D, it is a non-metal because it is on the right side. It is on the right, and it is a gas. So there you go. It's a non-metal because it's on the right, and it's a gas. The periodic table is arranged in order of, well, it's arranged in order. Each time you look at it, the atomic number increases, which means the protons are being added. So periodic table is arranged in order of protons added. So hydrogen has 1 proton. It's the very first element. Helium, 2 protons, second element. Then flip on down. Lithium. Lithium has 3 protons, third element. Arranged in order of protons added. Atomic mass on the periodic table progressively changes left to right and top to bottom because, well, again, guys, what did I just say in the previous question? We were adding a proton. Electrons really don't matter. Their mass is negligible. So those two, B and D, are wrong. C, a proton's being added. And if you look at a periodic table, that should make sense. And guys, these questions, you should probably look at one when you're trying to answer them. Since the element cobalt is located to the right of the iron, which of the following can be predicted about its atomic mass and atomic number? Well, it's to the right, guys. That means we're increasing because atomic number increases as you move to the right. So that means it should have a higher atomic mass and atomic number than iron. There you go. So B is the correct answer because we've added 1 proton. So technically our mass should increase. An element found in the upper right of the periodic table would, so the upper right, over here, okay, have where's barium? Barium is all the way over here. So would it have a higher atomic number or a lower? If it's in the upper right, it should have a lower atomic number, right? So higher atomic number, higher atomic number. Okay? Now, would it have a higher atomic mass than barium if it had a lower atomic number? No, it wouldn't. So correct answer is D. It would have a lower atomic number and a lower atomic mass. The atomic mass of an element represents, okay, what does it represent? The atomic mass represents the average mass of all its known isotopes, okay? Not the total, it's the average. It's not the average mass of protons and neutrons, nor is it the total. This is mass number, and there is a difference. Okay, mass number is the number of protons and neutrons, but the atomic mass is the average mass of all the known isotopes. Okay, the atomic number of an element represents, hey, I hope you're jumping up and down like my dog is. She's waiting to tell you the answer is protons. Okay? So, the atomic number of an element represents the number of protons. Which of the following explains the difference between atomic number and atomic mass? Well, remember we said the atomic number is the number of protons. Okay? Atomic mass is an average of isotopes. Okay? So the atomic number is the number of protons, and the atomic mass, well, that sounds like it. So let's just double check. The atomic number is the number of protons, and the atomic mass is the total mass of protons and electrons. Electrons would never be considered a mass, so that's wrong. The atomic number is the total number of protons and neutrons. No, because the atomic number is just the number of protons. D, the atomic number is the total number of protons and neutrons. Again, that one's wrong because it says protons and neutrons. Correct answer is A. The atomic number is the number of protons, and the atomic mass is the average mass of known isotopes. Only 2 isotopes of copper exist in nature, copper-63 and copper-65. Which of the following is true? The atomic mass for copper is the average of the 2 isotopes, or 64 AMU. No, it's not, because it's not the average. It's a weighted average. It's based off how many are there. So if we had 25 Williams and we wanted and only 4 Shelleys, and we wouldn't say, oh, 25 out of 29 and do an average that way. No, we would do a weighted average so that we'd really show how the data was represented. Okay? The atomic mass of copper is the total mass. Nope, it isn't. The atomic mass is the average. There you go. It's the average abundance, guys. Okay? And hopefully you would look at a periodic table to figure this one out too to help you out. 25. How many protons are an element with an atomic number 25? Is everybody else jumping up and down? I'm jumping up and down. I hope you are, because you should know that this is 25. Atomic number equals number of protons. Okay? Question. How many electrons are in a neutral atom with an atomic number of 12? Well, if it's neutral, so neutral atom, in neutral atom, the number of electrons equals the number of protons. Okay, which means then it would equal the atomic number, which is 12. There you go. Use the table below to answer the following question. What is the following could be the atomic mass of element 26? Well, if this is 54 and this is 58, it needs to fall in between, right? It shouldn't be less because it has more protons, so that makes that one wrong. And it shouldn't be more because it has less protons than cobalt. So the correct answer, there you go. Okay, next question, guys. Hopefully it's helping you out, this tutorial. Predict the properties for elements. Well, first off, what is cadmium? If you're not sure, you should hopefully know that tin is a metal. So if tin is a metal, that means this one should be a metal, because we don't really break, because we're on the left side of the periodic table. It means cadmium's a metal too. Okay, what would 48 blank 50? So this is 49 because we're going in order. Okay, as a metal with an atomic number 49, approximate average atomic mass of 114. That actually makes a lot of sense. So let's keep going and make sure that's the right answer. It is a semi-metal? Nope. It is a metal. It is a nope. And nor is it a gas. So the only correct answer, and by knowing, even if you just known tin was a metal, and that everything to the left of tin would be a metal, you would have got the answer right. So I hope this short tutorial helped you out. Remember to study, guys. Thanks. Bye.